When you talk about a single microservice, it's very easy to build one. You can use any of your libraries and create a service. And they all have multiple clients which can talk and connect to the service and get things done. Now, this is good for a single service. But if you want to add scaling to the service and add other kinds of concerns, monitoring, observability, and those kind of stuff, we soon get into more issues, right? You can certainly add some load balancers and some kind of services in between to help you out over there. But that's not the case, right? When you have lots of services, right? And this is typically what you would see in a typical deployment, where you have tons of services connecting to each other, and things can go down. There could be multiple failures. There could be different kinds of messaging formats between these services, and so on. So when you build something like a service cloud, it's not just about building a single service and having clients connect to it. You have to worry about a lot more concerns than what you're seeing over here. And that is where I think what you see on the screen is not just going to be enough. We have a lot of things you'll have to address for. And this is just a small sampling of things which you can expect. There's, first of all, you have to start with the decomposition of all the services that you have in your domain. How do you connect them together? What kind of gateways will you have? What kind of ingress and outgress rules will you have? Of course, observability is very important. So you want to do tracing, monitoring, and things like that, and set up dashboards on top of it. You also have to deal with failures, which will probably happen very frequently in a service cloud. So these are the things which will probably concern yourself with when you think about a big service cloud. Now, people have created lots of patterns, right? And people have written books about it, and they have created things so that some of these concerns which you saw in the earlier slide have been addressed already. And I don't expect you to read this slide, but you can imagine that there's a lot of these patterns already out there. And implementing them individually for each of those concerns that you have is obviously going to take a lot of time. Now, what you want to do is jump into an area which is becoming very popular these days, which is microservices and Node.js. These two things put together are some of the buzzwords which you can hear in pretty much everywhere on LinkedIn and other places. Now, in the Node.js world, things are going to be very different. You'll have lots of packages addressing each of those concerns. You'll have Express for creating your API gateways. You'll have communication, security, monitoring, all of those things taken care with various kinds of packages out there. And you can imagine that once you're building a microservice at scale in terms of service clouds, these are the kinds of things you'll have to concern yourself with. And it can become very challenging. And instead, you're spending a lot of time dealing with these kind of things rather than worrying about the business logic of your application. So just to kind of summarize, right, a single microservice now is now having lots of additional concerns around it. And this is what I think Rakesh also mentioned in his talk, where a microservice, when deployed onto a cloud, is no longer just about simply addressing a business function, but also catering to all kinds of additional things that can happen while a service is on the cloud. Right? Things can go down. You need monitoring on the service. You need to apply some metrics, and since you have so many different services deployed, there has to be some discovery mechanism so that people know, the service cloud knows how to talk to various different services deployed together. Now, that's where molecular actually comes into play. And this is kind of setting the context for molecular and why we think we need a framework like this in Node.js. Now, addressing those concerns that we saw earlier obviously is not easy and straightforward. And so what we really need is something that can kind of give you a framework and a more holistic approach to building service clouds, where the focus for a developer is more on the business logic rather than the details of the infrastructure. So molecular actually addresses all of these things in a very wonderful way. It is fault tolerant, takes care of these things out of the box. It is extremely fast. The throughput is actually really good. And it kind of fits things together in such a way that everything's very extensible. So if you feel that you need a different kind of a tracer, you need to pick a different package from the CNCF Foundation, you could do that. You can switch your logging framework, you could change your transporter, all of those kinds of things. So let's go a little deeper into what molecular has to provide than just the top level surface that we're scratching over here. So just to kind of kickstart the whole thing, molecular is actually addressing all of these concerns of a microservice for you. At the heart of this is the service broker. And this is a very common concept that you see in any microservice deployment, right? A service is the one which actually does the business logic, but it needs a companion to go along with it, which is the broker. And the broker takes care of talking to other services, providing logging, infrastructure, metrics, health, etc., etc. And these are all the things which the broker can do for the service. So the service is more focused on just the core business logic. Now, a service in itself in molecular consists of actions and events. Actions are the things which the business logic, it's the business logic operations that you can perform on the service. And think of them as CRUD operations. These are all things which you modify the domain entities which are residing inside of your service. At the same time, since the service sits inside a cloud, you need to have events that you want to handle when others are firing certain things, right? When you want to be notified when certain services have finished doing certain things, or other raising certain domain events inside your cloud, and take action on them. So service basically sits at the ecosystem in this ecosystem where it can offer commands that can be fired following the same CQRS approach, but it can also listen to other things happening inside the cloud through events. And that's what you as a business developer is going to be mostly focused on, building those services, enabling those actions, and then listening to notifications happening inside the cloud. If you go a little deeper over here, these services are actually deployed on nodes. And you could have several such nodes inside your infrastructure. And each node needs to have a broker. And this is the broker which will actually enable communication between various services also deployed on the same node. And through the broker actually uses transporter, which then talks to other nodes on the same cloud. So this is how you can achieve scaling as well. So you could have some services which could be, say, plenty in number because the service is pretty hot. And there could be other services which are not so frequently used. So you could be on a node which has fewer scaling factor applied onto that service. But all of these services deployed on different nodes on the network communicate to each other through a transporter. And a transporter could be something like NATs, or it could be a Kafka queue, or it could be simple TCP/IP communication happening over some channels and established through the transporter layer itself. And all these systems over here are pluggable and extensible. So it's not that you have to go with something out of the box that is given to you by Molecular, but it could be anything that you want to use inside your own client's system. So the heart of it is your service, the service broker, and all of the communications happen through the transporter between the services. And the broker is the one which kind of establishes the communication across the entire cloud. Now, all these concepts are great, but let's get into the action and the more meatier action about actually building a small checkout workflow. And let's see how this can be done in Molecular. So it is a typical checkout representation. Obviously, it's not as complex as you would see in a retail domain, but still it kind of gives you a feeling of what checkout has to go through. So when a user fires off checkout, they have added all their items to the cart, and now they're doing a checkout. Right? At this point, cart is your singular service, which is acting as the entry point into the checkout operation. Now, this cart will actually fire off first a request to the pricing service to ask for the price across the entire order. And that will be used to kind of apply your deals, your promotions, coupons, etc., etc. And then finally, it gets a value, which is the amount that needs to be charged for the cart. And now the cart has to then take that amount and then apply the charge onto the user's payment method. Now, this is typically done by talking to a payment service. And since payment is its own little ecosystem of services, it's not a request response over here, right? The communication that happens between the cart and the pricing is a request response. So it's happening synchronously. Whereas the communication that happens between cart and payment is asynchronous. The cart simply fires an event notifying the payment service that I need this charge to be processed, but it has to wait until the response comes back. So the cart service actually has to listen to notification coming from the payment. And that is why that arrow that you see between the cart and payments is actually a dotted arrow. It's a asynchronous communication happening over there. And similarly, when the payment comes back and says, okay, everything went through properly, cart has to talk to fulfillment to process the delivery and other kinds of shipping related logistics that has to happen for the particular order. So this is a typical checkout workflow, which is very common in any retail e-commerce system. And we'll see how we can actually implement this in code. Now, this is where I'll have to jump off to a space which is probably more comfortable for my being. The stage is kind of getting very uncomfortable now, right? I mean, I don't want to sit here and show you code. I would rather jump to a place which makes more sense for code itself. So let me do that. This is much like it, right? This is the kind of space I like to be in most of the time, sitting at my desk and hacking away at things. So let me just share my screen quickly and show you the code itself. All right, so let's take a look at this. So to start off things, we have the Docker Compose file, and this is what I'm using to set up a bunch of services. And we have NATs, we have Zookeeper, Kafka, all the usual suspects you can expect inside a service deployment. And what you see over here is I'm also using Jaeger for open tracing. So this is something I just set up, and it's running in the background over here. And you can see it running in the terminal, and all the services are up and running. And just to kick off things, let me show you the broker itself. Before we jump there, let's see the package JSON. Now, this is where you would actually set up all your molecular packages. We have started off with molecular, and there is one for DB, there's one for Jaeger. As I said, these are all extensible, so you can actually even replace this with your own tracing system if you have it. And I'm using molecular web for the API server. These are all the packages which you would need to kind of use molecular. And there is a simple example I'm going to start off with by showing you the notion of a broker and a service. Right, so here is a broker, which is a service broker, which is using NATs for its transportation and all communication happening between brokers. So we have created a service on this broker. And remember that every broker, there's only one broker per node. And on that node, you can deploy multiple services. Right, so the broker kind of coordinates the communication across services on a node. So what we're doing here is on this broker, I'm going to create a service, which in this case is a very simple product service. And I'm creating one more service, which is the API gateway that acts as an endpoint into your service. So I'm exposing the get endpoint, which literally talks to the action called products.bread. So whenever I request for products, I'm going to get back the bread as my primary product. And notice that in this, I have an action called bread, which takes the context, and the context is the broker's context, and just simply returns the product, which is simply your name and price and so on. So this is a very simple setup for a service. And then I'm simply starting off the broker at the end so that all of this comes into life. This is typically how you would think about as a developer. And imagine a situation where you're focusing more on your specific business functions, creating domain-specific logic. You would have these things focused and distributed across teams. So as a developer, your life is mostly concerned and limited to the service creation, creating the actions, organizing actions and events, and so on. So let's take a more typical example, right? And I talked about the cart service. So let's see what a cart service looks like. This is a little bigger in size, but what you can expect over here is that you have actions. Oops, sorry. You have actions which are like add item, adding items to the order. You can add a payment method. You can then do a checkout and also request for status of your order, right? And so these are all the actions that you're exposing from this particular service. At the same time, there are events which you need to listen to, such as payment completed and payment failed. And these are the events which will be fired by the payment service, so that you know that for this particular order, what has happened for the payment detail. So that's what this service is all about. And it is using a few mixins like a database so that it can keep track of its own state. Notice that since I'm using my own database, it is using database per service pattern. And it is not something you have to think too much about, right? It's just a mixin for you. And so this action, I won't go into details of what this action is actually doing, but notice that this add item action has some params defined. Every time you add an item to an order, you are specifying which user is doing this, what product you want to add, and how much quantity, right? And these parameters are already validated. So in the sense that if you don't supply these parameters in this particular fashion, it'll actually fail for you. So molecular takes care of the validation aspect so that you don't have to worry about how this action is being called and whether users are calling it properly or not. By the time your handler gets called, you can be rest assured that all these parameters have been supplied and you have every one of them. Now in this, I'm using the adapter, which is my database adapter, and simply looking up the user ID and checking if they have a cart object already created. If they have a cart, then yes, you can go ahead and process it. But if there's no cart, I'm going to create one for you, which is by creating a new object and putting it in the database. And then from then on, I'm going to update the cart and adding the items that we just asked for in the action. Similarly, we have the add payment, which is also having some parameters, and it also checks there's a cart already present, and then updates the cart by adding the payment method. So this is all good in code. Let's take a look at Postman and see how this works out. So I have a product now, and I'm going to add this add product, which is literally calling cart add, and it passes this particular data, right? User ID, product ID, quantity, etc. Now, if I don't supply this quantity, so let's say I remove this field and then fire off my request, right? You see that there's a validation error shown right over here. So this is what Molecule is doing for you out of the box. It tells you that for this particular action, you didn't supply the field quantity. So let me add that, and let me add 1. And now when I send it, it made a request and it said, okay, now you have a cart, and there is one product called product 1 added to with this particular quantity. I can also add one more product. So let's add one more. And now you can see that my cart has product 1 and product 2, and this has 3 items in it. If I add this again, I'll have product 2 again. And I'm not doing the totaling of the quantity across the 2 products, but that's something you guys can do. I'll show you the Git repo so where you can make these kind of fixes as well. Now, when I do a checkout at this stage, it's actually going to fail because it says that there's no payment ID associated with this particular cart. So there is some checking happening at the code level also to ensure that all the parameters required for doing a checkout have been supplied or not. So let me go ahead and make that fix. Let's add the payment. So now we can see that we have a payment established in the response. So there's a payment ID over here. And now when I do a checkout, you can see that it works. And yes, the cart status has changed. And now the whole process of checkout has started. Now notice that this is not a response coming directly from the checkout, because at this stage, you have simply fired an event from the cart notifying the payment service that a charge needs to be processed, right? So it has to wait until the payment completes. And for that, we expose an endpoint called status, which is again very typical in a lot of e-commerce setups, where you'll have a status endpoint for your payment. And now that the status is completed, the whole checkout process is complete. And this is something you would normally handle on the user interface side, where you'd constantly keep pinging the status endpoint to see whether the payment processed or it failed, or whatever is the state of the payment. And that's where you will actually take it off and then move the user to a different page, like a thank you page or something. So in code, what you will see over here is that that's exactly how we have done it. So the cart service actually has a bunch of these action methods exposed, right? So there's an add payment where you're ensuring that the cart exists, and then you're adding this payment into the cart. And then when you do a checkout, you're first checking that you have a payment associated with the cart. And if there isn't one, then you'll obviously fire this error and notify the user. And then on, you're going to kick off the payment process by, so it's over here, I think so, yeah. So you'll start off over here by first getting the price. We'll talk to the pricing service. And notice the way I'm doing this call, right? There is a context.call that is happening. And this context is the broker for this particular service. So all communication that happens between services is through this context. And I'll simply call the pricing.get because that is the action that I need to invoke in order to get the price of my items. And I'm passing the user and I'm passing the items which are there in my order. And I need to pass this user because a lot of things and deals and coupons, promotions, etc., could be associated with the user. So the pricing service uses that information and then gives you the final price of your cart. And once I have the amount, I can then invoke the checkout process, right? So I'm emitting an event over here. So this is not a request response, right? At this stage, I'm only emitting an event and saying that, okay, hey, this cart needs to be checked out for this particular user using this payment method and for this amount. Notice that the payment service doesn't care anything about the items in the order, right? Because that's not the concern of the payment service. It only needs to know what payment method to use, for which user, and what's the amount to be charged, right? And that's all I'm going to emit from over here. When you go into the payment service, notice that the payment service, which is identified by the name payments, there is an event called cart.checkout. And that has all the details that you need for the payment. And then it does some simulation and randomly fails our passes. In fact, if you go back to our Postman and do a checkout once more, let me do one more checkout, and it says it has started over here. Sometimes the status could also be failed. Oh yeah, there you go. So we just put a simple random failure, which is a random failure over here. So sometimes it could fail, sometimes it could pass. We can do checkout a couple of times, and maybe this time it will pass. Yeah, this time it completed. So we're doing a random failure just to simulate what could happen when you fail and when you complete the payment. And once the payment completes, you have a reference ID. This is typically used to do for auditing, for generating invoices, and so on. But we haven't really dealt with all that over here. This is just to kind of show you how the orchestration happens from the cart service across all the other services, right? So when you do an entry point into the checkout, it is talking to your pricing service, which is over here. And the pricing service is really simple over here at this point. I'm only receiving my order and the user, and I'm always returning 100, right? Because I just like that number 100. But it could be more complex over here. This could actually talk to the products, get the information from the product catalog, then apply various coupons. All kinds of things can happen in the pricing stage. And you could come back with a number that is the final price of your cart. And then the cart service eventually, when everything completes, so which is the event, right? So it has to receive the events. So it receives the completed event, which when the payment goes through completely, it then emits an event called cart.checkoutComplete. Now this is a notification that also goes out to the fulfillment service. The fulfillment actually listens to this and then does whatever it needs to do in terms of creating a delivery slot, or in terms of creating some supply chain logistics, getting all the vendors to come together, or looking at the inventory and seeing if the fulfillment can actually happen or not. And if something cannot be done, then this is a separate process that is kicked off from the fulfillment side of things. From a user's point of view, the checkout is now complete anyways. So this is how I think the whole molecular thing works. And so if I go back to the stage, which I'll do in just a second, I just given a glimpse of what molecular can achieve. Let me go back to the stage now. So we're back in action now. So you saw what we could do with molecular, and if you go to the next slide, you'll see that a lot of these things I'm giving you is just a glimpse of what molecular can do. And I would really urge you to take a look at molecular and try using it for your clients' services and see if that actually benefits you a lot. In my opinion, when we used it for one of our clients, I think the development time reduced dramatically. Instead of the team focusing on infrastructure needs, we were more focused on building the business logic. And I think there was an initial 1 or 2 weeks of learning, but I think that was very quick. And after some point, people can understand the concepts. The abstractions that are there in the framework were quite few, right? You just have actions, events, services, and brokers. That's about it. And most of the time, you would be dealing only with these abstractions. And I think even juniors on our team could actually learn these things in a week's time and were able to deliver services very quickly. So I would all of you guys should definitely take a look and see. Look at the demo that is there over here, and just to kick you off, and how you can use molecular in your own projects. And hopefully this is useful enough for you guys. And thank you. And if you have any questions, happy to take it right now.
Thanks a lot, Pavan. I think one unanimous response coming on the chat is it being very crisp and very useful.
Yes, you can. In fact, molecular DB. So the question is, can I use a different DB than molecular DB? Well, absolutely you can. Well, molecular DB happens to be just an adapter. So you can replace your adapter to talk to Mongo, Couchbase, it could talk to SQL Server, Postgres, could be anything. So there are adapters for all of these different databases, and you can simply change that in the settings for the molecular. I didn't show you the molecular config, but in the molecular configuration, you can actually set up what's the database, what's the adapter to use, on which port is it hosted, and all those kind of things. You certainly do that.
Next question is how production ready is molecular?
So molecular is already, the question is how production ready is molecular. In fact, molecular is already being used on a lot of different places. A lot of startup companies are using it very heavily for building their services. And I think there are more than 100 companies at this stage which have used molecular. It's almost, I think, 3-4 years old in terms of the lifetime of the project. And a lot of things have been tested, and it works pretty well. One thing I didn't show you was the automatic connection with the open tracing. If I had time, I would have shown you that. But I don't have enough time to do that.
So one question is, does molecular also have options or pre-built modules to support stuff like GraphQL, federation, or gRPC communication?
Yeah. So the question is, does molecular have inbuilt support or any packages that can do GraphQL or GraphQL stitching and federation and things like that? Absolutely. GraphQL is actually supported officially, and you can simply replace the transporter to use GraphQL instead of Kafka.
One more question is, how is the performance of molecular JS compared to well-established microservice frameworks like Micronaut and Spring Boot or non-concurrency front-end?
Yeah, so the question is, how is molecular in terms of performance against frameworks like Micronaut or Spring Boot, let's say? I would say it's a par because Node is a very IO-driven framework by itself, right? And so are other frameworks as well. So most of the time is actually not spent in the framework itself, but actually waiting for responses coming from the APIs. So in terms of performance, I think it's very comparable. Yeah, so I think we're just running out of time right now. I would have shown you a few other things, but there's one thing I didn't show you was the automatic tracing that gets set up when you connect molecular with something like Jaeger. Right? You saw that running in the background. What would I shown you if I had more time was the fact that the Jaeger's dashboard automatically discovers all the services and shows it to you with all the spans across all the traces running across services. But that's something for future maybe. Any future questions, any other questions you have, I think you can take it over the chat. I'll definitely, more interested to answer over there. But for now, I'll hand it over to the next speaker who's waiting eagerly for you guys. Thank you, guys.